Hello, everyone. I'm Mike Urbans, and welcome to It's Your Water. I'm glad you found us. Well, PFAS. Everybody's loading up the bandwagon. It's the hot new topic in the water filtration industry, and I'm here to address it with another technology, because I'm seeing, a proliferation of 20-inch big blue cartridges with resin and media blends, but they're still cartridges, and I have a little bit of an issue with that in that people forget about them and they become basement orphans, as I call them. And it just really concerns me. But today, it looks like A.O. Smith may have a winner in the whole house category. And to discuss it is Justin Mest. And Justin is a product application specialist at A.O. Smith. What is NAWT engineering, Justin? What's acronym? What does that mean?
North American Water Treatment Engineering.
Oh, okay. And a really smart guy. How you doing? Thanks.
Not too bad yourself, Michael.
Thanks for coming out and doing a live in the newly renovated podcast studio. Justin's done a few other podcasts with us. One of them is very popular, the pH one. That gets high listening. So welcome back. So to get into this, AO, they created HomeShield, and they just rolled it out, and I was very intrigued at how they've engineered this, and Justin had a big part in it. It's a multimedia 1252 tank. I call it a one-tank wonder with a blend of, let's call it top secret, patented PFAS Slayer media. I'm going to let Justin take it over from here, but the intriguing part is they got a 500,000 gallon capacity on this, and that's pretty cool. But Justin, why in the first place, and we've beat this to death, but why should we worry about PFAS when it's like everywhere in our clothing? We hear this, it's everywhere. But first of all, why worry? What's the big driving force out there for people to worry?
So I think when you look at PFAS distribution in the environment and what we're exposed to, it's really critical to properly evaluate things like dermal uptake versus oral uptake, right? So a lot of PFAS, or at least a lot of the regulated PFAS, don't readily absorb through your skin. Some of them do, but even though most of the ones that do have pretty low percentage of uptake. Mm-hmm. So even though you might find some really scary numbers, like you referenced shirts, right? Mm-hmm. A lot of shirts contain a lot of PFAS in them, but depending on what PFAS is in that shirt, you might actually absorb practically none of it through your skin. And actually, I was recently having a somewhat comical conversation with a salesman about the difference between exposure and uptake. Because, right, in my mind, those are two very different things. And exposure just means like, hey, you're interacting with it. Uptake means you're actually absorbing it, or you're uptaking it into your body in some way or form. And that's where it's really going to be of concern. Mm-hmm. So when we look at uptake, dietary uptake, non-water-based dietary uptake, so whether it's from food or food packaging, getting into your leaching PFAS into your food is actually one of the biggest ones. That represents about 67% of studied PFAS in terms of uptake into our bodies. So that's hands down the biggest one. Number two is dust inhalation. So things like, you're kicking up your carpet and you have an old Scotch Guard carpet or something mm-hmm. like that, and it's coming up and you're breathing it in via dust. That's the second biggest pathway at about 9.94%.
Makes sense.
And then drinking water is number three at like 7.49%. So drinking water is the third biggest contributor in terms of an exposure route that we should really care about because we directly uptake it into our bodies. Mm-hmm. And once again, the uptakes of concern really depend on the specific PFAS, and this is a pretty nascent area of study. In fact, I remember at WQA mid-year, someone brought up the concern about we don't really know much about PFAS exposure pathways.
Right.
And I raised my hand and I was like, the research community is already working on this for several years. There's actually already some good data out there. Mm-hmm. So it's a very common misconception that people have. And I think when you learn about it, that's really, as so often the case, education is the name of the game when it comes to making like wise decisions as a society. And I think this is another really good example of that. Is like, yeah, PFAS exposure to anything is bad, because I always like to say contact time is a function of time and concentration, right?
Mm-hmm.
Just like disinfection, but in this case, in a really bad way. But at the end of the day, it really comes down to the specific PFAS and whether or not you should be worried about it being in your clothing or in your drinking water, so on and so
Yeah,
forth.
it's amazing because, you see a lot of, I think New York State banned PFAS clothing. And I think there's a couple other states, but we're close to New York. So it is kind of interesting that the dermal uptake might be a little less than the your drinking ingestion. So the HomeShield, again, is just a one tank. We always see multiple tanks out there. And the thing, when I did my research with you guys on the tank, because, I have a little skepticism with new things coming out, and I scratch my chin. I'm like, oh, here we go. Here's something else. And the internet is a very big wild, wild west for things like this in our industry. So I always warn people to be very, very careful. Of course, a company as big as A.O. Smith would have done all these studies. How were you able to do what most people do in a 2-tank system, to do it in a 1-tank system? We were talking before about column testing and flow dynamics. And that's what intrigued me. Your tank is not just an empty tank with stuff in it. It is truly an engineered, plated flow dynamic type tank. If you can give us a little bit on that and how you achieved what you've done, your capacities and the removal goals that you've achieved. So
Yeah, so I'll start with some background on the piece you hit on in terms of column testing versus like a full-scale actual system. So column testing is an awesome tool for researchers as well as for pilot testing applications in the field, because it gets you answers in a much more practical, much more time-efficient manner. But something that often gets ignored is, while we use these columns and they contain, or at least they should contain, the actual media you're using, the flow distribution in a column is so much more even than any conventional tank system you're going to find out there.
because it's in a lab, right? A tank. What is a column? A column is
a column is literally just picture like a pipe.
a pipe.
It's a long, thin piece of pipe that you load your media into, and you flow in however, if you're doing upflow, you got to do upflow. If you're doing downflow, you got to do downflow.
Yep.
People do them in series. It's meant to mimic a full-scale system.
Gotcha.
And if you're designing your columns properly, you need to do things like match your empty bed contact time, bed depths, hydraulic loading, all of that
All
jazz.
that stuff, yeah.
Which, most people do, but the piece that still gets missed is the fact that the flow distribution in a column is so much better. And to sort of put numbers to it, based off of some internal testing we did at A.O. Smith, a conventional single tank design, like if you take a 12 by 52 mineral tank with an upper strainer and an in-out head and a Vortex plate and stuff like that, or really any plate, you're looking at still about 43% worse flow distribution or more uneven flow distribution than a column. So that can really dramatically reduce the capacity of your system. At A.O. Smith, we ran a bunch of modeling via software to try to come up with an ideal design and really properly understand this issue. But then we also coupled that with actual direct testing, where we made some clear tanks and observed how flow actually moves with things like dyes and things of that nature to really understand what's going on inside a mineral tank. And we have a patent pending flow distribution design in that tank that can achieve nearly the same flow distribution dynamics as a column, which to me, that's sort of it's honestly the proudest, the thing I'm most proud of at A.O. Smith for two key reasons. One, the accomplishment is huge, but two, and most importantly to me, NAWT engineering, the engineers for this product saw an issue.
Yeah.
And there was a loophole that we could have taken.
Yeah.
And we decided to not do that because they're ethical folks. And they said, no, we can't in good conscience ignore this issue. This is an issue we need to solve.
Yeah.
So I would argue the biggest piece of the magic behind HomeShield is that internal flow distribution system.
Mm-hmm.
And I'm obviously like, I can't talk about too many details because it's patent pending, but...
Of course. But that's what's a neat thing. And that's what really, quote unquote, sold me. And that's why you're here. You have an NSF 53 certified capacity. What is that? The NSF is the big, National Safety Foundation, or what are they? Sanitation.
National Sanitation Foundation.
Yeah, I get it. But they are the big mahaf of the guardians of the industry, where, they say, look, here's where you have to meet, and then they'll give you the stamp. And they are very credible. They're very tough.
There are a lot of things included in NSF ANSI 53. First of all, just like pretty much all of the NSF ANSI drinking water standards incorporate some sort of equivalent to NSF ANSI 61. And in a nutshell, what that tells you is the thing's not going to blow up, and it's not going to add anything dangerous to your water.
Right.
And honestly, that's super important in the drinking water world because, like I teach all the time, in water treatment, every time we do something good, we do something bad as well. That's just part of water treatment. And it's really about balancing the good and bad. And part of making sure you don't do bad is the bad could be adding unsafe chemicals into the water.
Yeah.
So NSF ANSI 53, one of the most important elements is it gives you confidence, it's structurally sound, and it's not going to leach anything dangerous into the treated water.
Yeah.
The second piece is NSF ANSI 53 is specifically focused on health-related contaminants. So whether it's lead, PFAS, mercury, all of those are going to fall under NSF ANSI 53. So HomeShield is specifically certified for 5 different PFAS under NSF ANSI 53. And what that gives you, right, is it gives you a level playing field for comparing product to product, but it also gives you confidence in this is not A.O. Smith saying we can do something. It's not any manufacturer saying, hey, my product will do this. It's a third party. It's an independent organization validating. I always describe it as it's them telling us you are allowed to say this.
Yeah.
And that 500,000 gallon capacity, the standard goes as far as even with a PID, a flow-based PID, like what HomeShield has,
Right.
a way better flow meter than most of
Right.
what we most commonly see in the industry, by the way, but there's still a buffer on that 500,000 gallons capacity. So we actually achieved significantly more than that, so in NSF ANSI 53, if you have a PID, you need to actually treat 120% of your claimed capacity. And we actually went way, way beyond that, and we were still non-detect.
Which is really cool, and which is where the basement orphan thing comes in. And that's where, so your PID is a life meter that you put on the outlet of this thing. So yes, indeed. I do seminars with Justin, and I do them on PFAS and other VOCs and activated carbon. And the risk of recontaminating is out there. It's big. And it's kind of like the hidden boogeyman in our industry. And I preach and preach and preach. If you put a water meter on there and a physical water meter, and at least you have a gauge and something that someone can't get in there and reset, Now, this one has your life light, which is the green, yellow, red, which red is dead. So a customer can go down and see how well it's doing. So what makes your flow meter a lot more different so I'll tell you what, that's probably one of the most important parts of this bugger.
Yeah, and so it's a modern ultrasonic flow meter, right? Which ultrasonic meters have been around for a really long time, but they were crazy expensive until pretty recently.
Yeah.
And one of the biggest benefits, in my opinion, of this meter is its low flow detection capabilities. This meter has been validated to detect flow rates as low as 0.01 GPM. But I'm not going to say that it will always detect that flow. It is capable of detecting that flow. It will reliably detect to 0.09 GPM at about plus or minus 5% accuracy. And once you get to about 0.44 GPM, that accuracy jumps to plus or minus 2 to 3.
Yeah.
So if we compare that to like a turbine meter, right? Most turbine meters are, I'm going to say, specified
Yeah.
at 0.25 GPM on the low end. But anyone who's used to turbine meters will probably tell you that no, I would personally never trust a turbine meter to actually detect that low.
Right.
In my mind, it's like, yeah, once you get below 0.5, it's like dicey at best.
Because it's a physical thing that you have to spin in the water flow.
And it gets gunked up, right?
Right.
Contaminants build up on it. There's more resistance there. With an ultrasonic meter, you're literally shooting a light beam into the water, and it's reflecting off of two surfaces and measuring how long it takes, to traverse that distance.
Exactly. I did AQmatic has a ultrasonic for big systems, and they're stupid accurate, and the only thing that kills them is air bubbles, that'll give them a little fit, but who has air bubbles in the water? You shouldn't have air bubbles.
Well, and that is one important thing to call out about ultrasonic meters in general, including this one, right? The orientation of the meter for HomeShield does matter. And this is, of course, all specified in the installation instructions and everything. But if ideally the meter is positioned so that it's running horizontally, but if you have the meter positioned vertically, the water needs to be going up through the meter. If you plumb an ultrasonic meter, including this one, vertically and the water path is going down through the meter, it's probably not going to pick up the flow at all. So it's really important. That's an important thing to note for installers out there. Ideally, we want it horizontal, but you can put it vertical. But if you do, make sure the flow path is going up through the meter.
Yeah, never knew that.
Yep, that's a big one with ultrasonic meters.
Yeah, but they are cool. That is. So it's pretty much a very highly engineered system with a safety built in.
Yep.
It's easy to install. It's a single tank, so it's going to save you so much time on install, and uses the Clack 1192 in-out head, and it comes with the V3006 bypass.
Yep.
And a V3007 fitting kit. That's all Clack speak. Everybody knows what they are. So it's a complete package. Boom, you get it. Nothing to add, and everybody knows how easy they are.
You take it out of the box, you thread on your bypass, you thread on your tail pieces and your PID, you plumb it in your roll.
So basically when it's done, let's get into that. I mean, I'm reading some notes here that we added, but we'll get to when we're through with it. But the price points, people are going to think about that. But if you do the math at a retail level, at 500,000 gallons, I always tell everybody, it's almost free. Yeah. Water is 0.01, like 0 cents per gallon treated.
I think this one for typical list pricing comes out to, I think it's $0.0077 per gallon. So it's less than 1 cent per gallon
treated
to treat the water.
And that's the value in it. People are like, it's a little bit of money for us to do this, but once you roll it out that way, I say it's free. Well, and now you know why the bottled water companies can still give you a giant packet of water, because the water costs nothing to filter in a vast scale. So that's a big value to customers out there.
And I would say another big selling point, too, of that capacity is not only cost, but also maintenance burden, right? If you compare this to like some of those cartridges you referred to earlier, like even the really big suckers.
Yeah.
This HomeShield, depending on how you configure those giant like spa-size cartridges, it has anywhere from 400 to 800% higher capacity, right, which translates to 10 to 20% the maintenance. Rather than having to go down and change out a big, heavy, frankly, probably messy cartridge
right,
at least like once a year, you plumb this in, you leave it alone when it runs out of capacity, which is realistically is going to take at least 5 years.
Unless they're filling pools and running their lawn.
You shouldn't be doing anyways. Yeah, bypass your
lawn doesn't care about PFAS.
Yeah. maybe your garden, maybe use it to water
Maybe
your
your
garden,
garden.
because
Okay.
vegetables will take up the PFAS.
PFAS,
That's
yeah.
part of the dietary uptake component. So if it were me and I knew I had high PFAS, I might use it for my garden specifically.
But still.
But only the garden. Yeah, the lawn, no. Don't treat the PFAS for your
don't go
lawn.
going crazy with that. But we have that flow meter. It tells us. And shame on you if you blow through that much. You're just going to have to get a whole new tank. So that's the next part of it. When it's finished, I guess what they do is they'll drain it out. I've come up with things for guys, and I'll run this past you, is that if it's reached its capacity, but secretly, wink, wink, we know it's not dead. So I tell guys to create in their toolbox an air coupling with a low volume air coupling and a ball valve and a clack fitting, put it on the inlet, and then take the outlet off with a clack fitting and a hose adapted to it. And on the downflow, blow the water out. Just purge it with a low volume of air. Blow the water out in the service, because you know that water that you're blowing out is treated, and you're blowing it out of the tank in service, and makes it a hell of a lot lighter and is to dispose of, because what are we going to do? Dispose of the whole tank, right? We cap it. I say maybe get a clack fitting kit with caps, and away it goes.
And it's totally legitimate to dispose of it in a landfill per current regulations, right? Disposal regulations are in reality always in flux. I certainly wouldn't expect that changing anytime soon with the current regulatory environment, right? They're certainly not going to get any stricter right now when it comes to disposal. And that's also, it's another very active area of research at a lot of different levels in terms of like PFAS leaching off of spent media. I'm part of some of that research, actually. I can't share details, but that's a legitimate area of concern that we need to address as an industry. And thankfully, we are actively pursuing knowledge on that so that we can address it as an industry. But yeah, right now, it is totally legitimate to, if you want to, you can throw in the trash, or if you want to send it to their environmental companies that specialize in PFAS destruction that will take media. If you want to spend a little extra money and you really, really want to make sure you're not reintroducing into the environment. But I would advise folks to wait just a little bit longer, because there's some research that should be coming out pretty darn soon that has some more definitive answers about whether or not we should be worried about PFAS leaching out of spent cartridges and medias.
And this basically is a vessel, an enclosed vessel.
Yeah, I literally talk about it like it's a giant cartridge. Because of the complexity of that internal distribution system, which once again is a big part of why we're able to get the performance we get, you can't rebed this thing in the field. Which in my mind, right, I know, once again, like the sales team was all like, oh, it's going to be this big deal that we can't rebed in the field. And I took it upon myself to survey a bunch of dealers at WQA and WQA mid-year and just talking with contacts in the industry. And every single dealer I talked to said, PFAS? No. I don't want to rebed. I want nothing to do with that media.
With it.
Like, I'm just going to throw out the tank anyways. So this system, you can't rebed, once again, because of the complexity of the internal distribution system. And there are multiple medias in this tank, and they're positioned right where they're supposed to be. So there are a lot of reasons. And we're vacuum packing the system at our manufacturing facility, and even the startup procedure. Like, we have really thought this thing through. Even the way you flush the system, it's not just open a faucet and let it run until it's clear. You do that. But then we came up with a specific way of, we call it surge flushing in engineering, that actually makes sure that in shipping, that media might move around a little bit. So we came up with a special startup procedure that we validated internally to make sure this is how you repack that media if it came unpacked during shipping.
Yeah, because a lot of guys like to throw them in the back of the truck, and you should keep it vertical.
Oh, yeah. I would definitely advise keeping this vertical. We have tanks hooked up. We're testing the impacts of laying it on its side. But yeah, definitely you don't want to lay this thing down. It's the rule of the MTZ, right? The good old mass transfer zone dynamic. Yep. Once again, that media we put that media right where we want it to be. The tank, depending on the apparent density of the vessel, that tank might be stuffed to the gills. It might have a little bit of freeboard in it. So if you get a unit that has a little bit of freeboard and you lay it on the side, you are going to get potentially some degree of media transfer. And not that the system's not going to work at all, but might it reduce your capacity a bit? Yeah, it might.
Yeah, you should. So, thanks, Justin. I mean, just a quick recap is that indeed I started this off as a one-tank wonder, but it is an engineered little marvel that you guys come up with because you laid back and you watched the industry and you said, let's see how we can do the better mousetrap here. And that's why I'm excited to have that opportunity to have these units because, I'm the supplier to the world of activated carbon and tanks. And that's the way we do it is 2 tanks, either ion exchange resin or activated carbon. That's all we have right now. But this has the capacity, a much higher capacity, say, than say cartridges and things out there. Plus, it has the water meter to monitor the capacity.
And the independent certification, right? And something we didn't even talk about with the certification is the reality is that, especially based off of the UCMR5 data, this system is certified to a capacity of 500,000 gallons at influent water qualities that you're practically never going to see in the real world. Way more challenging, I should specify.
So you spike that water pretty hard.
Oh, yeah. It's almost 1,900 nanograms per liter of PFAS.
Right.
Around here, having grown up around here, I'm used to seeing total PFAS concentrations of 200 would be whoa, wow, that's high.
That's high. Yeah. You got what?
Yeah. So once again, I really want to drive home the message of the certified capacity is a really big deal because, and it's really important to make sure that you compare certified products to certified products because there are competitors out there. I was looking at a competitor that says if you look at their raw product, it's basically the same cost per gallon as ours, but they challenged it with a total PFAS concentration of 240 nanograms per liter.
Right.
And I was like, okay, well, it got brought up once again by the sales team. I was like, guys, this is really easy to crush. Just pay attention to the details and you should be able to sell against this all day. And that's a non-certified system. So it's really important to, once again, make sure you're comparing apples to apples when you're looking at products.
Be careful of that, the internet Wild West.
Yep.
And the recontamination of the basement orphans. That's a big concern. Okay, you want to wrap it up? Thanks, Justin. I really appreciate you coming. I think we're going to have Justin come in the future and talk about microplastics. There's a tease for you. Thank you, and thanks everybody for listening. Trust the Frog. Bye-bye.